So you just read about the student T distribution and confidence interval. So let me just recap that, and maybe if it didn't make sense the first time, hearing it a second time will be helpful. So the idea behind the student T has to do with the standard deviation. So we're gonna change a couple of things in this formula, and really the basis is we're no longer going to work with a population standard deviation, but now a sample standard deviation. So you may have noticed in the previous problems in this chapter, the way they phrased the standard deviation, they always said, assume the population standard deviation is such and such. And maybe it occurred to you at some point, hey, how is it that we know, the population standard deviation, but we don't know the population mean, right? That's what we've been creating confidence intervals for. Like the population mean is unknown, yet somehow we do know the population standard deviation. I mean, that's harder. Like, how is this possible? So here's just a quick history of the student T distribution. For a long time, statisticians would use a sample standard deviation and assume that it was equal to the population standard deviation, right? So they would find their sample, they would take the sample average, that's x bar. So they would know x bar, and then they would say, okay, I found the sample standard deviation S, but I don't really know what to do with S, so I'm going to say that that's really just equal to sigma, the population standard deviation. And that's what we saw in those formulas, right, with sigma. Okay, so that works really well if you've got a big sample size. So if you've got a sample size of 50, or even as you get up to like 30 and things, that's kind of the cutoff, then that approximation, just saying that they're equal, is you can get away with that. Okay, so about 100 years ago, this guy, I forget his name, he worked for Guinness, the Irish beer company. Okay, so he was doing these samples on his barley yield, and he was, seeing, he's like just experimenting with his barley and his wheat and things like that. And he had these really low sample sizes. We're talking like 10 or something like that, like, definitely under 30. And so he tried to do his statistics in the same way people were doing them, assuming the sample standard deviation was the population standard deviation. And his numbers were just not coming out right. It was obvious this was not correct statistics that he was performing with his confidence intervals and his other inferential statistics. And so he came up with this whole new student T distribution and confidence interval. It gets that name because when he published his work, he referred to himself as student. So he, like, as he's writing, he's like, I, the student, and then he happened to pick the variable t, and so it became known as the student T distribution. Okay. And kind of interesting that it's connected to Guinness, I think, too. All right, so here's kind of the gist of it and what we can take away. Very similar formula for the margin of error. But now instead of a z-score, we have a t-score. And instead of sigma, we have S, the sample standard deviation. Now what's really nice is there's a t calculator in StatCrunch. So we're not going to use the normal calculator any longer. It's not a normal distribution. It's a student T distribution. Luckily, StatCrunch has a T calculator. One thing, the other big difference between a T distribution and a normal distribution, so the first one is the standard deviation, but the next one is the degrees of freedom. When you do a student T in that calculator, it's going to ask you for the degrees of freedom, df. And without going into any detail, the degrees of freedom is always one less than your sample size. So take whatever n was, take one away. All right, let's get into practice number 4. Okay, so I'll just show this. Let me go ahead and read it. The number of hours people sleep at night is normally distributed. 10 randomly selected people were asked how long they slept the previous night. The sample mean was 7.1 hours with a sample standard deviation of 0.78 hours. Find the 95% confidence interval for the mean number of hours people sleep at night, and we'll round to 3 decimal places. Okay, so we've got our 2 formulas, right? We've got our same formula for the confidence interval based on this margin of error. So let's go ahead and find all of our values. This is kind of the equivalent of the first practice problem we did. We're just kind of walking through getting this confidence interval. Okay, so let's go ahead and find all these values. What is X bar here? It says 10 randomly selected people were asked how long they slept. The sample mean was 7.1. Okay, well that's X bar, the sample mean. Okay. With a sample standard deviation of 0.78. That's S. What is N here? I think we already read it. It said 10 randomly selected people, so our sample size, N, is 10. And finally, we need to get the value of T to plug into our margin of error. And as I said just a moment ago, we're going to go to our T calculator in StatCrunch. Let's see if I can fit all of that. So if you go back to where you pick all the different calculators in StatCrunch, we did the normal before. Now we can switch it over, do what they just call simply the T calculator. And you'll see this towards the bottom. You also notice the shape of the distribution looks a lot like the normal distribution. It's typically thinner and skinnier than a normal distribution, but it has that same sort of bell shape. Okay. Also be sure you're using the between. At the top, there's the standard and the between. Again, we want the between. So at the bottom, it's going to look just like this, and there's probably some default numbers that you see in each of these boxes. We're going to have to enter in the degrees of freedom for our case. Well, what is the degrees of freedom for our problem? And we said a moment ago, it's always one less than the sample size. So we're going to put in 9 right there. And we're going to type in the confidence level here. In this problem, we want the 95% confidence interval. So we'll put in 0.95. We'll enter in those two. We'll hit compute. And hopefully you get these values here. That's what I got when I did it. Okay, negative 2.2622, positive 2.2622. Again, it's always going to be one positive, one negative. All we care about is the positive version. Also, it kind of bothers me, so I feel like I have to mention it. They put an X there. They mean T. They mean a capital T. They use X for everything. All right, anyway, that's the number we're looking for. That's the value of T. And so we're going to put everything in. We've got our T. We've got our sample standard deviation. We've got our sample size. Computing that right there. I invite you to do that as well. It got me 0.558. I rounded to 3 decimal places. That's what they asked for. And we have the margin of error. Once we have the margin of error, We're looking really good. We're really close to the answer. It's the same approach now. To finish it off, we're going to take our point estimate and we subtract the margin of error, we add the margin of error. Our point estimate from the beginning was 7.1. So we'll add and subtract 0.558. And here's our final answer. That's our 95% confidence interval. 6.542, 7.658. We are 95% confident that the real population mean falls somewhere between these two values. Okay, so yeah, just a slight change in the approach, but really feels so similar, right? And if you wanted to think, hey, how could I recognize that I need to use a T calculator versus a normal calculator when I go about a problem? And how do I know I'm looking for degrees of freedom, right? And that sort of thing. It's all about that standard deviation. So if they say the population standard deviation, you know you're working with sigma, and that's a normal calculator. But if they say the sample standard deviation, you know you're talking about S, and so you need a T calculator to get the T. So kind of really be sensitive, I think is the word, to that. Did they give me a population standard deviation, or did they give me a sample standard deviation? And that's going to continue for several chapters as we do more inferential statistics. Okay, let's go to number 5. And I'll just present it. Start off in the same way. Okay, let's read this together. The data from the National Fire Protection Association are a sample of the number of home fires started by candles for the past several years. The number of home fires started by candles each year are normally distributed. Okay. Find the 99% confidence interval for the population mean, and we'll round this to 3 decimal places as well. Okay. So again, we're kind of got to hunt for all this information and then go through those steps again. The big difference here, what makes this one different? They don't tell us the sample mean. They don't tell us the sample standard deviation. They don't directly tell us N, although we can get that pretty quickly. And then, of course, we'll need to use our calculator to get T. So let's start off by figuring out the X bar and the S, because that's really the shift here. So I've got this note. Really, what do they do instead? They give us these data points that I did not read the first time through. So they tell us how many home fires there at the bottom, right? 5,460, 5,900, 6,090, 6,310, 7,160, 8,440, 9,930. They give us the raw data. So here's what we're going to have to do. We're going to have to find X bar and S ourselves based on the raw data, right? Think back to chapter 2, right? We had to calculate sample averages, sample standard deviations by hand, given data. Okay, you probably haven't forgotten that. Turns out, though, since we're using StatCrunch more often, and because we already did those things by hand back in chapter 2 and you were tested on that, we've got better means now. Here we go. To find X bar and S, we're going to type the 7 data values into StatCrunch, just into the spreadsheet. I should be really clear. We're going to type them into StatCrunch as a column. We're going to go straight down the first column. Then we're going to have StatCrunch compute the mean and the standard deviation for us. So we're not going to do all that stuff by hand, but we are going to have to type in all the data and go for it that way. So I'll invite you, go into your StatCrunch. You're probably already there. Actually, here's the steps. Go into StatCrunch, type those 7 data values in as a column, right? So you'll have, it'll say like variable 1, and you probably know what I'm talking about already, but then we'll start to fill those in down the first column, those 7 data values. Okay, you get the idea. Fill all those in. Once you have these 7 numbers filled into a column, then go to Stat, Summary Stats, and Columns. And we did this before when you did a previous StatCrunch lab, that very first StatCrunch lab. And then you're going to highlight the mean and the standard deviation. And you can do those at the same time, and it'll tell you both, or you can do these one at a time. Doesn't matter. We just need those values. Okay, so if you might be doing that along while I'm talking, or maybe you're not there yet. I'm going to go ahead and tell you what those numbers are, but I want you guys to be doing it as well, and then you can confirm that you got those numbers correctly. So if you're still working on that, pause the video here, because I'm about to tell you what the answers are. Okay, so here we go. When I did it, I got these 2 values for the mean and the standard deviation, and I just took every decimal place that StatCrunch gave me. I don't want to round at this point, so for X bar, I got 7,041.4286, and for the standard deviation, I got 1,610.2736. Okay, so hopefully you got those same numbers. If not, go back. Maybe you didn't type in your data quite right. Maybe you had a flaw there. But now that we have these numbers, we can proceed. Oh, by the way, n equals 7. That was the number of data values that they told us, right? The 7 numbers. Okay, our sample size. So with that, I'm going to go to find the last piece that we need is our T calculator. And I'm just going to show you what's happening here. Get that off the screen there. Okay. So go into your T calculator, make sure that it's set to be between your degrees of freedom. In this case is 6, right? 1 less than 7. And you're going to type in an answer of 0.99. We're looking for the 99% confidence interval. And that's going to tell you that T, the positive one, is T equals 3.7074. And we're almost there. Now we've got X bar, we've got S, we've got N, we've got T. We can compute that margin of error. Right? Got my T, got my S, got my N. I came up with 2,256.421. Now there I rounded to 3 decimal places. And then to finish it off, we will add and subtract that with X bar. And I'm just going to jump right to the final answer. The lower limit on my confidence interval, 4,785.008, and the upper limit on my confidence interval, 9,297.850. when you take it to 3 decimal places. We are 99% confident that the actual population mean falls somewhere between here. And you can notice we are really confident, and that's quite a big spread, right? That's like 4,500 home fires started by candles. So quite a large, but hey, we can say we're 99% confident it's somewhere in there, and that's not nothing. That, you know. Okay. Um, so let's stop this video here. I will see you in the next one for proportion-based confidence intervals.